Hello everyone. In this video, I would like to share some math contest items which were set in Desmos. And here are the questions, and you can follow my links, which will be put down in the video below. You can see the questions here, and these are some questions used in the mathematics contest in Hong Kong for some upper primary students. And there are a number of items that you can preview quickly here. And I will also share with you some brief responses, okay, and we gather from the students in the dashboards later on. And here in the website, you can also freely copy the set of materials and adapt it if you like. And here are the questions, starting from question 1. You can try it Desmos and it's a preview. Okay, here are a number of questions, different ones that you can find out on this website. Okay, and apart from the questions here, we have also gathered some responses from students during the contest. And here I will show you a few dashboards, which one with about 40 students participating in the contest, right? And through their work, maybe you have some ideas of what the upper primary students in Hong Kong can do in this competition. And okay, in each of this dashboard, you can also see the summary here. Okay, these are the name, okay, given to the students. And so the real names are hidden. And also in the teacher's wheel, you can also quickly see the responses of the student. Like this one is the question 1. Question 1 itself is asking the student to find a triangle with the same area with the given one. And let's see what you can find out from the dashboard. Here are the students' responses, right? And you can also show the correctness, and then you can quickly see how far the student can answer this correctly. And if you click on the overlay here, just like what I see, you can also notice that quite a lot of students have chosen one or two particular case where the triangle is congruent to the given one, right? So this one generally is not that difficult. And how about the second one? The second one is also asking the student to make two triangles of equal area. And let's see the original question. This is the original questions. Okay. So unlike the first one, you cannot make these two triangles congruent. So you can only make the areas the same. Now go to the teacher's page again, then you can see the student responses. And now we click correctness diagram. And here you find that it becomes more difficult because there are just a few correct answers. And if you click on the overlay, then you find that there are far more choices for students to consider, and just which is different from the first one. For example, go back to the first one to have a look. I find that the answers quite, most of them are quite consistent in choosing one or two particular cases. And here you will find that there's quick variety in the responses the students are given. Right, so this shows that it's more complicated and more difficult for the students involved. How about question 3? Question 3 here, and you can find that they obviously cannot make the two shapes the same. So the students may be able to concentrate on the area this time. So let's see the result. Here is the teacher's wheel. And here you will find that the correct answers now actually is more than the previous one. Okay, so there are far more correct answers. And if you look at the overlay, you can see that the student can concentrate on finding the area which is the same as the quadrilateral. Okay, so this one is more successful, right, among the students. So these are what we can see briefly in the students' responses if you examine the dashboard. So you can see similar situation in other districts because these are other dashboards. Okay, and then here's the one from another dashboard as well, which is very much the same. Well, what happened in another group of students in another district participating in the contest. And okay, and now let's look at the other questions. The next one we can go ahead. Is this one, right? This is asking the student to make an isosceles triangle in question 4. And these are the result. Okay, in this case, it's quite easy. Actually, all the students are correct, I think. Yeah. So you can find that they can quite easily make an isosceles triangle in this case. How about another district? Here is another dashboard, and you can also see the results are quite similar. And let's see the third group. I'm now clicking on the third group. And this one, yes, also quite similar, actually. How about the fourth group? Let's have a look. Okay, oh, this one is a greater variety. Okay? So you can see that because they can find out actually 3 cases of isosceles triangle. Let's look at the responses in the individual one. Now, basically, most of them are correct, actually, just like the previous 2 cases. But at the same time, there are a variety of correct answer because there are different cases of making the triangles isosceles. Yeah, so that is quite good results from the students. And let's turn to number 6. Number 6 is about making an symmetric shapes, okay, just like this one. But it looks like that is the more difficult, actually. If you look at the teacher's results, and you find that many of them are not able to make the symmetric pentagon. In this case, if you check the correct result, only a few of them can make it. All right. So this looks more challenging for the students anyway. Okay, let's look at another question. Now, this number 6 is also very interesting. I will have another video later on to talk about how students work on this question and also some interesting extension that we can try with this question as well. Okay, so let's elaborate on this one later. Okay, now go to number 8 and 9. Right, we are asked to arrange these expressions from highest or from largest smallest one. Okay, and so the students can easily move around these numbers and arrange them. And here are the results. So these are the individual students' results, and then you can check the correctness. You can roughly see how many students are correct in these cases. And then here is the overlay. And the overlay, you can find that which 2 expressions are more difficult for the students. All right. And generally, the biggest one, the smallest ones, are relatively easy for students to determine. And let's look at another district. Just wonder whether they have very similar results. So let's check it again. So this is about, yes, the same question in another district. So it looks like the performance is better, but still these 2, I think these, yes, this one, third one, sorry, the fourth one is more difficult for students to determine how big it is. Okay, let's look at another one of arranging expressions. This one is about fractions. So they also asked to arrange them in the order required. Now in the teacher's page, and this is the correct answer. Not too good again. It's quite challenging for the students, I would say that. And here's the overlay. All right, and you click the correct answer. Obviously, these 2 are difficult to determine. All right, and that's why relatively most of them make mistake here. Okay, next one is about using the balance. We use also the polypack for this kind of questions. So they arrange the numbers on 2 sides and then try to find out the results. And let's look at the teacher's page here. We cannot do the overlay, but generally you can find the students can successfully balance the scale in all the cases here. All right, so that can be easily seen on the page. And the next one is also about balance. They also ask to find the unknown while balancing the scale. Okay. Some of them make it more complicated, but generally they can still find the answer, although they can find the answers in different ways. Okay, so here are the result summary, and these are all to get the correct answer, and only a few make a mistake. Right, so good. So this one is quite good for many students. Okay, the next one is about fraction bars. So they are asked to find the length of the grade 1 by arranging the fraction bars and find out its length and calculate it. And so these are the results. And here you can see that the picture also shows that many of them can successfully find the fractions matching with the grade 1, right? And although some seems to do it in more than one way, and the numerical answer is also showing that they can get the result. So this is 19 over 20 by the length, and only a few make the mistake here. Okay. And the next one becomes more challenging, I think. Let me see. Here is the summary, and only a relatively fewer students can get the correct answer, and the rest are wrong one. So how challenging it is? Let's look at it. And actually, in this case, okay, they have to match the length in this way. Okay, so it have to add two subtraction and then subtract one in order to find the grade one. And that make it more complicated and difficult for many students actually. Right? But it's good to see a variety of results trying out by the students. Okay, now we have three more questions. The question 13 is about using the protractor, and then try to measure this angle, which is the smallest one in the triangle. And these are the variety of answers coming out from the students. And so you can see, yes, there are different answers. And yeah, not very good here in this case because only this group of students can find the correct measurement. And maybe the other ones are not that used to using the protractor yet, so by finding angles of a polygon or a triangle. And we can also see some snapshots. That means if you are interested in some of these cases, and you can group them together and then share it. And here you may find a variety of interesting results. For example, this one, you wonder why the student consider the angle is 5 degrees. And by the way they put the protractor will give you some hints about how they get the answer. And this can be some question for our further investigations. And then here similarly, another one. And this one, you can see the screens. And they also, the students show that the angle is 90 degrees. Okay, is it something that they takes from directly from the diagram when they use the protractor? And how about this one? Okay, and how come the answer 30 degrees coming from this measurement? One interesting thing is that actually these triangles have been rotated by 30 degrees. So I don't know whether this is one of the reasons that students will consider that the angle is 30 degrees when they make the protractor aligning with the triangle. And here, one more maybe. And that is also quite interesting to find out why this 1 degree. Similarly, it is because the students have all just rotated the protractor by 1 degree in order to match some of the angle here, perhaps. Okay, so these are what we call snapshots from the answer, which can also pick up quite easily for discussion with the students later on. And if you jump to the last one first, because last one is also about using the protractor. And here we are asked to find the percentage of the green area in the circle. It's not directly about the angle, but using the angle to find the percentage. And here you can find, so more or less the same group of students can get the correct answer of 10%. And the other one should give different answers, but we may not be able to know how different answers come out. Okay, finally, the second last one, question 14. It is about a solid, okay? And here you can see the student can drag the solid in order to examine different part of different faces of the solid and count the faces, edges, and vertices. And so if you look at the teacher's page, actually the result performance is quite good, although many may make mistake here. And here's the summary. Many know that they have 10 faces, it has 10 faces, but also quite a lot think that there's 8 faces actually. And how about vertices? So many of them are correct in telling that it is there's 8 vertices. There are a variety of answers wrong here in this case. And here is the part about for edges, okay? So quite a lot of them can count, and it's very challenging actually, but still they can manage to find that there's 16 edges. And then at the same time, quite a number of them make mistakes of different kind. We can also quickly look at another district, see where the similar results come up, because we have different groups of students trying out the questions. So that's why we have different dashboards. And just quickly have a look of the same question here. Also, 10 faces, very good. But some may also think that the 7 and 8 and wonder why they counted wrongly. Okay. And similarly for edges, okay, vertices. So quite a lot in this group, knowing that there are 8 vertices. Okay. And edges, here we can also get the summary, 16 edges, but also quite a lot think that there's a 14 or 12 edges. Okay. And this shows some common mistakes among the students in counting the edges, which is good to follow up if we have a chance to discuss with the student. So thank you for watching this video. This is what I'd like to share quickly with you about the students' responses. And if we have time to analyze and discuss further, we may have another opportunity to maybe share with you the results and also discuss in other workshops online, perhaps. Okay, so keep in touch. Thank you.